Hi guys, this is Dynamics Lecture 1. We're starting off with velocity and acceleration. Everything's basic here. So everyone should know velocity, average accelerations and everything. And next, special cases. These are all the basic four, these are all the four basic equations in physics we learn in high school. People represent it differently. This is how I like to do it. Yeah, the first example. I'll keep the video going so you can probably read it. Yeah, so what do we know? We know the initial velocity t0, then u is 0, and then we know the upward acceleration is 1.5 g, and we have to find velocity at time, and the distance is 30 kilometers. So over here 30 kilometers is 30,000 meters, and then this is what we know, and here's the acceleration. And first we have to find x equal ut plus half at squared, and we substitute all the values in, and over here make sure the acceleration is 1.5 multiplied by 9.81, because 1.5 g, the g over here is gravity. I feel like there's something wrong over here. No, I think it's all good. Alright, next. So this is everything basic as well. Yeah. Vectors. We are going to use a lot of vectors apparently. This is also high school mathematics. Over here y is represented as j and x is I. So for example, if there's a velocity diagonally over here, say, again I can't come up with anything right now, so basically we can represent it as something like 2i plus 2j, and yeah, something like that. So r is equal to xi plus yj, should be j over here, yj. Ooh. Yeah, that's a really bad j. Yeah. And next, magnitude and directions, and finding the magnitude of a vector. So you need to find the magnitude of this. That means you have given an x, a j value and an I value, but how do you find the real magnitude of it? You have to square each and then square root of the whole thing. So as shown over here, and mainly the direction is found by an angle. And this is the next example, 1.3. Alright. Yeah, finding the average velocity. So we have to find the distance. When you do something like this, make sure you do I and j separately. So sum of this and these two is over here, and some of these two are over here. It will come up to this. And as I said before, to find the average velocity, you have to square root them. And this symbol, I think it means finding the magnitude. And yeah, so that's the answer. And to find the angle, you already know it's 1.5 minus 2.5 over here, like over here. So 1.5 on the x directions and negative 2.5 in the y direction. So you draw a triangle like that, and I think it asks to find the angle, the average velocity to the x-axis. So this is the x-axis, and find that angle. So that should be easy. Projectile motion over here. Let's see. This is basic as well. Just make sure you remember there's no acceleration unless given horizontally. So the only acceleration, so if it's like a projectile motion, the only acceleration acting will be downwards. That's gravity, and there'll be nothing horizontal. And this is the same for basic equations, just in a different way. And the next example is 1.4. I'll give it some time to read. All right. So what do we know? So when we come across a question like that, we should first write down the horizontal and the vertical components of each. So we horizontal and vertical components, yeah. And so what do we know? We have the acceleration as negative 9.81, and initial velocity, final velocity, and over here, yeah, basically this is all we have. And first we have to find the time to reach edge. So for that we have to apply this equation horizontally. So halfway through in the question is the maximum height. So halfway through horizontally is 11 feet. And yeah, so when we put everything what we have over here into this equation, we should get the time as 0.36. And to find the velocity at start, so now we know the time, we don't know the edge. This is what we have to find, and we know the acceleration. So the velocity at start vertically, and converting 9.8 meters per second squared to feet second squared is 32.2. Make sure that that's something really important, and that's a mistake that I always do. And v equals u plus at, and yeah, that's easy. We're finding h. So now we know most of the values we need, and then just plug in to v squared plus u squared plus 2as, and you'll get 2.17. This is an extra question. I'll give it some time. This is the same as what we did before. So this is what we know. These two are what we know. This at this time and this at this time. We have to find the magnitude of the average acceleration and angle with the x-axis. Let's see, just as we did before, the average acceleration is the velocity divided by time, and yeah, we do that. We find this is the average acceleration and vectors, and then the magnitude, and then this is the angle. It's easy as that. And that's all what we learned in lecture 1 this week. And I'll be posting up a tutorial soon as well. And thank you.